In this video, I'm going to look at sampling distributions. We might be looking for the sampling distribution of the mean, we might be looking for the sampling distribution of the median, or any other statistic that we could find from the sample. If I'm going to do that, I will need all possible values of the statistic, together with the probability that each value happens by chance alone. To do this, I shall have to write down all possible samples together with their probabilities, then calculate the value of the statistic for each sample. The sampling distribution of this statistic is a table of all possible values of the statistic together with their probabilities. Okay, now let's have a look at an example. Here we have a large bag containing $1 and $2 coins in the ratio 3:1. A random sample of 3 coins is taken and the mean is calculated. Find the sampling distribution for the mean. Well, we must first find each possible sample, its mean, and the probability of that sample. And here I have a table showing exactly what I've just said. We can have all 1. That obviously has a mean of 1. As there are 3 $1 coins to every $2, the probability of a $1 coin is 3/4. So we have 3/4 cubed is a probability of 111. That's 27/64. Then, if we're methodical about this, we could have samples where there is 1, 2, and 2 1s. These will all have a mean of 1 1/3, but they are different samples because the 2 occurs in different places. 2 1s, probability 3/4, 1 2, probability 1/4, 3 samples, probability 27/64. Then, of course, I could have just 1 1 and 2 2s. All have a mean of 5/3, which is 1 2/3, 3/4 for 1 1, 1/4 squared for 2 2s, and 3 samples. Gives us 9/64. Or we could have had all 2s, mean 2, probability 1/4 cubed, 1/64. Always worth adding to make sure that we've actually got these right without making a silly mistake. 27 plus 27 is 54, plus 9 is 63, plus 1 is 64. So we've actually got this right. So the sampling distribution or probability table of the mean, this table now, which is at the bottom of the screen, the mean 1, probability 27/64, mean 1 1/3, 27/64, 1 2/3, 9/64, and 2 1/64. So this is the sampling distribution of the mean, or the probability table for the mean. Let's look at another example. Let us suppose that a disease is present in 23% of a population. A random sample of 30 people is taken, and the number with the disease, D, is recorded. What is the sampling distribution of D? What is the table of probabilities for all possible outcomes of D? Well, what possible outcomes of D have we got? The number with the disease could be any number from 0, 1, 2, 3, up to 30. And then we need the probabilities. I've summarized these here. Your possible outcomes are 0. They're all people without the disease, 0.77 to the 30. You could have 1 with the disease is 0.23, and 29 without the disease is 0.77 to 29, happening in 30C1 ways. There's a general term, and they could all have the disease, probability 0.23 to the 30. This we recognize as the binomial distribution. So in this case, we don't actually have to give a probability table. The sampling distribution of D is binomial 30, 0.23. So you will either be giving a probability table as a sampling distribution, or it might be that it is a standard distribution which you can recognize and write down in a shortened form.